Today we are from Group 6 for BMM 3521 Fluids Mechanic Lab. Instructor name Sir Muhammad Amarnik Mutasim, and our group members today will present about the lab report for Bernoulli's theorem. So we are consist of 5 people in this group. So first of all, let me introduce Nur Iman Balkis binti Shamsul Kamar with an ID of MA19235, and then Nurul Amira binti Muhammad Nasir MA19291, me myself Hani Bernaduni anak Winston Rajid MA19245, and then Badrul Amin bin Badrul Hisham MA19235, and the last one would be Muhammad Izzuddin bin Jamal Abdul Nasir MA19209. So first, it will start off with introductions by Nur Iman Balkis binti Shamsul Kamar.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nur Iman Balkis binti Shamsul Kamar and my ID number is MA19235. Today, I will present about Bernoulli principle experiment. I will cover for chapter 1 introduction, while other chapters will be covered by my team members. Without further ado, I will explain the background for Bernoulli's principle. Bernoulli's principle specifies increasing in the speed of fluid will exist at the same time with decreasing of static pressure or fluid potential energy. It was named after Daniel Bernoulli, who published his book in 1738 titled Hydrodynamica. Leonhard Euler obtained Bernoulli equation in usual form in 1752, even though Bernoulli assumed that decreasing in pressure when increasing in the flow speed. Next, the principle is only fitting for isentropic flows, that the effects of irreversible processes and non-adiabatic processes like heat radiation can be neglected and small. Bernoulli's principle can be applied to various types of fluid flow that will result in numerous forms of Bernoulli's equation. The simple form of Bernoulli's equation is valid for incompressible flows, for example most liquid flows and gases moving at low Mach number. At higher Mach numbers, there are more advanced forms are applied to compressible flows. Bernoulli's principle can be derived from the principle of conservation of energy. Lastly, Bernoulli's principle also can gain directly from second law of motion of Isaac Newton's. There is more pressure behind than in front if the small volume of fluid is flowing horizontal from a high pressure region. This results in net force on the volume accelerate along the streamline. Now, I will clarify the problem statement that obtained from this Bernoulli's principle experiment. The first problem statement that occurs for us is we have to wait for the air bubble to disappear and water level to stabilize for 10 minutes until 15 minutes from the multi-tube manometer. Secondly, we have to measure the flow rate. And lastly, we have to calculate the velocity, pressure, pressure head, velocity head, and total head. After that, I will show you the objective of Bernoulli's principle experiment. The first point for objective of Bernoulli's principle experiment is to investigate the variation of total pressure head, static head, and dynamic head. Secondly, we have to determine the static head measurement, and lastly, to study the total pressure measurement. In closing, I will spell out the scopes for Bernoulli's principle experiment. Firstly, we have to use multi-tube manometer and read on the top portion of the apparatus to take the reading for static head measurement. Secondly, we have to use pitote tube and read on the right side of it to take the reading for total pressure measurement. And we have to use Venturi tube to differ static head and dynamic. I will pass to my other team members to present about the next chapter. That's all from me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. Hi everyone. Good morning to my lecturer. Okay, my name is Nurul Amira binti Muhammad Nasir. My ID student is MA19291. Okay, this is my part in my group lab report, that is chapter 2 with title Theory of Bernoulli Theorem. Okay, we from group 6 and we are doing lab 1 for our first lab. Okay, in this chapter, I will explain to you guys briefly about what is theory of Bernoulli theorem. Okay, let's move to next slide. Okay, theory of Bernoulli theorems. What's mean by the theory Bernoulli theorem? Okay, first, in this experiment, we conduct the experiment to define the relationship between flow velocity and static pressure. Okay, this experiment we conduct is, the main objective is to find the relationship between velocity and pressure in a fluid, in a flowing fluid. So, we conduct this experiment using Venturi machine in lab, and we jot down the result in our lab report. Okay, secondly, there are two conditions in Bernoulli theorem. First, when velocity increase, pressure decrease. And second, when velocity decrease, the pressure will increase, vice versa. Okay, next point, theory of Bernoulli theorem, also known as principle of conservation energy of a fluid. What's mean by conservation? Conservation itself means safe. So what's mean by safe? This principle also use and point out that we use the principle as to save energy of a following fluid. So we minimize the energy to get the result. Okay, let's move to the next slide. To be continued, point number 4, we use Venturi machine as a testing parameter and static reading as fluid reading parameter. We use both of these items, both of these setup, both of the apparatus to jot down our result after conduct the experiment. So when the Venturi machine stop analyzing, stop working, so we take the result using static reading on the beside of the bulb manometer, and we read and jot down the result in our lab report. Okay. Next, what is Venturi effect? Venturi effect is a reduction occur in a fluid using pressure. When we apply pressure in a fluid, there will be reduction occur in the fluid, so that will make the fluid flow in extracted section. Force the fluid to go out through the extracted section, or choke, because we apply pressure, so the pressure will push it out. Okay, next, Bernoulli principle was invented by Daniel Bernoulli in his research in year 1883. It states also in Wikipedia there are one more people involved in this theory, that is Giovanni Battista. He also involved in Bernoulli theorem theory. Okay. Lastly, why Bernoulli theorem is important? It is important because in our course fluid mechanics, Bernoulli theorem is used to express relationship between pressure, velocity, elevation, friction in a fluid for exceptional state of liquid that is incompressible fluid along a streamline. So must be used on incompressible fluid along a streamline to get the result. So that's briefly explain about the theory. I guess that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Yusudin bin Nasir from Group C. I will talk about the method of experiment. So, for the Bernoulli principle experiment, we will verify with the use of a tempered duct venturi system connected with manometer to measure the pressure head and total head at known point along the flow. So the apparatus is hydraulic bench, Bernoulli apparatus test equipment, and a stopwatch. So for the procedure of the experiment, place the apparatus on the Bernoulli bench and ensure that the flow tube is positioned above the volumetric tank. Second is level the apparatus base by adjusting its feet. And the third is install the test section with the 40-degree tempered section converging in the flow direction. And fourth, connected the apparatus inlet to the bench flow supply. Close the bench valve and the apparatus flow control valve and start the pump. And the fifth, the following steps should be taken to purge air from the pressure tapping point. Firstly, close both the bench valve and the apparatus flow control valve. Remove the cap from the valve. From the air valve, connect a small tube from the air valve to the volumetric tank and open the bleed screw. Open the bench valve and allow flow through the manometer to push all air from them. And lastly, open the air bleed screw slightly to allow air to enter the top of the manometer. And retighten the screw when the manometer level reach a convenient height. The maximum flow will be determined by having a maximum and minimum manometer reading on the base. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Badru Amin bin Badru Hisham, MA19234. I will continue the presentation about result and calculation for Bernoulli principle experiment. Okay, we have here the data given, which is we have the time and the volume is constant, which is the volume is 5 liters and the time given is 25 seconds. Okay, I have calculated the flow rate, which is the flow rate is 0.2 meter cube per second. We have the static head of the water, the height. We can call the height for 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6, which is has different height on the static head. Although the Python head also have the different height on each point. So this is the graph of the static head and total Python head, which is the static head is the height on the manometer. You can see from this from 0.1 until 0.6 there is changes in the test pipe from point 1 to point 6. Okay, so the data given, there is a different diameter on the venturi pipe. Okay, this is the figure I just take, but we have 6 points for the diameter is different. On each point we have 6 points. Point 1, we assume the point is here, point 2, 3, 4 and 5 and 6 on the venturi pipe. So it will come out with the different level of water on the manometer. Okay, the data given in millimeter, but I changed to meter for easy on calculation. Next when we do, okay, the flow of fluid from this side to this side. Okay, this next is the formula for the calculation that we use. Okay, we calculate the area, which is the formula is pi d squared over 4. The velocity Q over A, which is flow rate over area. Okay, for the flow rate we have calculated before, which is we use volume over time. Okay, the pressure we use rho Vg over area. The pressure head we use pressure, static pressure over rho G. Okay, the velocity head we calculate with the formula V squared over 2G, and we get the next formula is calculated total head, which is H plus V squared over 2G. Okay, let's see the calculation that we have made. Okay, the calculation and the data we get on point 1, point 2, point 3, point 4, point 5 and point 6 is here. That we can see the constant value is the flow rate, which is the Q, that have no change. Okay, because the volume and the time taken is the same on the data given. The others is changed because the area is different, because the diameter we get before is different on the venturi pipe, which is the tempered duct lah. Okay, then we come out with this data. And how we get this data? By the calculation we make on each point. Okay, this is the calculation for area and flow rate. Okay, the point 1, how we get, we use the area formula that we have come out with the formula pi d squared over 4 pi. So we just take the changes is the diameter. Okay, for point 1 we have 0.0284. Okay, point 2 change, we take the diameter 0.0225 and get 0.0397659. Okay, this is for area, how we get the data for the each point. The flow rate, as I taught before, we use volume over time, which is the constant 5 liter and 25 seconds. So we get the 0.2 meter cube per second. Okay, next is the calculation velocity and pressure. This is the calculation that we have made for velocity and pressure. With velocity, we use the flow rate over area. The flow rate is constant, so the changes is the area that we have calculated before, and we get the answer for each point. The pressure is, we use the rho Vg over A. So the rho is 1000, the V is the volume, is 5, and the gravity 9.81 over A. We take the calculation from the area before and put it in here, and we get the answer for pressure. This is static pressure. Okay, when next is we calculate the calculation for pressure head and velocity head. Okay, the pressure head, we use the pressure over rho g. Okay, pressure we have calculated before, the pressure of the static pressure. Okay, take and over 1000 times by 9.81, so we get the pressure head for the point 1. Next we continue the calculation with the answer we get for the pressure, and we put it until we get 4.6. Okay, next we calculate the velocity. Velocity we use v or v squared over 2g. Okay, for v squared over 2g, we put the velocity that we calculate, and we insert in calculator and get the answer for each point. Okay, next we will get the calculation for total heat. So the total heat, as you can see here, the formula is h plus v squared over 2g, which is, but I calculate it just the answer plus with the answer, which is h is the total heat, and this is our sorry my mistake. H is the pressure head, and this is the total head. So we just take the answer we calculate for the pressure head and plus with the total head, so we get the answer calculation total head. Okay, so that this how we get the answer and the calculation. As we will see the discussion of this experiment, which is the experiment is we to investigate, which is it valid or not for Bernoulli equation when it's applied to the water or fluid at the tapered duct. The tapered duct here is the venturi pipe. We know the water or fluid or anything will take the shape of the container. So what is the changes? What happened when we use this Bernoulli principle? What happened to the flow rate? Is it fast or slow, lower? Is it have the higher pressure or lower pressure? What makes that is it change? Okay, so that's all from me. Thank you. Assalamualaikum.
So hello, I'm here today to present for the conclusions of this experiment. So the static pressure is reduced as the velocity increases, and in this experiment we can conclude that the objectives were fully resulting as predicted. Okay, the main objective of this experiment is to find and investigate the variables for pressure head, static head, and dynamic head using the Venturi machine. So this result was obtained by following the steps and procedures of using the Venturi machine. So after we have the result and data, we have putting the data taken for the each trial in the Microsoft Excel, where we have plotted the graph and also calculate the overall result, which lead this experiment to a conclusions where when the velocity is high, the static pressure is decreased. By the end of these conclusions, the data obtained was very predictable and also similar to what we have forecast at the early experiment. And yes, we can conclude that this experiment was a success as it worked following the principle of Bernoulli's theorem rules. So that's all from our group. Thank you.